Okay, so yesterday we left this number 2, the second half of the question, blank because we did not have the data yet of your homework. So yesterday it says here, what is the slope of your linear regression? So we found that already for yesterday, 0.98. But the second question says, is that similar to the slope of your line of best fit in number 3? And tell me why. So number 3, based on my line of best fit, let's go back really quickly of what my slope was. Where did that go? Oh, it disappeared on me. It just went. It just totally disappeared on me. Oh, love technology. Okay, let me go find it really quickly. Actually, let me just take yours then, because that way I don't have to waste time flipping back and forth. Okay, so on last night's homework class, what did you guys get on last night's homework? What was their slope? So look at your paper, look at number 3, what was the slope? Based on the 2 point you pick. 1? Okay, someone else? I'll pick a different value, some different values. Hannah says 1, someone else? What was the slope? 11 over 10, okay, yep, 11 over 10. So it's slightly over 1. Anyone else? I'll take some different values here so we have comparison. One more student. What was your slope from last night's homework?
16 over 15.
Yep, 16 over 15. Perfect. Can you see those are pretty much hovering around what? About 1. So based on the calculator, we got 0.98. Okay, Hannah got 1, and then 2 of you got slightly over 1. Okay, but are they pretty similar? But why are they similar? Why are they? You guys all picked different points. The calculator did it differently. Why are the slopes similar to one another? You have the same centroid? Yep, we all have the same centroid, that's true. But is the slope dependent on the centroid?
Because it's all in the line of best fit.
It is all in the line of the best fit. You're right. Yeah. Don't all the slope, doesn't matter what 2 points you pick, all came from the same set of data, right? So guess what? They are similar because they are similar because why? Because they have the same set of, yep, they have the same set of data. So fill this in your notes because we didn't answer this question. Okay. So yesterday we found the slope from the calculator and we wrote that in orange. Today we're trying to compare with, hey, calculator or handwritten? How are they related? Then yesterday we also found the y-intercept using a calculator. So today, okay, so Jacob, last night's homework, what was your y-intercept from your line of best fit? 0, what? So last night's homework, okay? Which is number 7 on your homework.
I think I had a little bit of trouble with it. I'll probably come in this order.
Okay.
Yeah.
So Emma H, what was your y-intercept, dear?
I got 9.72. I think it's actually 8.88.
No, mine was 8.88 because I used 2 different lines. You guys can all have something slightly different. So Emma, what was yours?
72.
72. Okay, I'll take maybe 2 more just to see. Dylan H, what was your y-intercept from last night, dear?
Mine was 8.
8, nice, okay. And just maybe 1 more. So Baron, what was yours?
8.06.
8.06, very good, okay. So as you can see, they're all different slightly, again, depending on how accuracy you did and what points you've chosen. But are they quite similar? Okay. And again, why do you think the y-intercept is quite similar? What's the reason? The 2 set of data are exactly the same. You're just using different methods to calculate. By hand, is it always the best system? No, because we have the thing called what? Human
Error.
right? Your 2 points may be off the line a bit because the 2 points is based on the line that you drew, right? What if your line is slightly different from the next person? So that's why graphing by hand, I should say, is never like the best accurate. You try your best and we eyeball it, but it's not always the best as the calculator or computer. So again, write that down. The 2, because it's asking right here, is that similar to the y-intercept of your line of best fit, and explain. Yes, it's similar because the data are still the same. Okay, so that is when you add that in. They are similar because you're using the same set of data. The number 4, we didn't have to compare anything at all yesterday. Okay. But number 5 is going to ask us. So number 5, okay, yesterday by using a calculator, we had 37.76, or we rounded to 38 points after practicing for 30 hours. Hannah L., what did you come up for last night's homework for practicing for 30 hours? One more time? 53.3 points, so 50, huh?
50.
Oh, 50. Thank you, Hannah. See, I'm just old, Hannah. Okay, so that's about 50 points. Okay, that's a lot higher than what we got by the calculator. How about Jack? What did you get from last night's homework?
I got
46 points from Jack. Okay, and then Brandon N over there, what did you get from last night's homework? 42. Okay. Then, how about last night's homework? Daniel F., what did you get? So after practice for 30 hours last night on last night's homework, what did you come up with? 38 points, okay. So you guys are kind of all over the board here. It should be, guess what? Should it be pretty similar? Yes or no? You can deviate a little bit, okay? So like, for example, by calculator, we got about 38 points. I would say you could deviate to maybe 42, I can see that, even 36, a little bit lower. But anything that's higher, so watch out for what, maybe it's an algebraic error, so watch out for that, okay? So guys, calculator and hand, they should be very similar. So, looks like the last one, 38, it's about right on, okay? And the last question is this. Which answer do you think is more accurate? The calculator or us doing by hand? The calculator, okay? The calculator will always be more accurate, or the computer? Yeah, it's more accurate. Okay, give me a reason why. One good reason. Why do you think a calculator is more accurate? Why? Why do you think the calculator is more accurate in finding the line of best fit? Very little human error. The only error I can think of is when you enter your data, right? What if you enter wrong data? Okay, so little human error. You're right. So spell that out, or whatever reason you think is best for you. Okay. Our next task is we are going to start and finish, okay, solving systems of linear equation, which is right below it. So we're going to go all the way down. Find this page in your notes packet, please. You have to copy these out right here. So as you guys are doing that, I'm going to come around and hand your homework for tonight. Tonight it's homework number what? 10. Don't forget to write 10 on it, please. And if you guys need to borrow a graphing calculator to do this, please stay at tutorial. You can borrow my graphing calculator anytime during tutorial. Today I'm going to show you guys, or pretty much sort of review, because this is an Algebra 1 skill, review how to solve systems of linear equation 3 different ways, okay? So the first method is called graphing. And I wrote down 3 steps that you can do when you're solving by graphing, okay? So Zoe, can you read me step number 1, please? Graphing.
So this is to a linear equation.
Oh no, like graphing, like the steps that we're gonna take. Graph the first line, you're right, okay? We're gonna graph the first line. Then step number 2, what do you do after? Gemma, after you always said graph the first line, what's step number 2?
Graph the second.
I know, graph the second line, okay? And Delaney, what do you want to do when you're done graphing both lines?
Solution.
Right, okay. Now what if, when you graph it out, and 2 lines are parallel? How many answers, Arista B, how many answers do you think you're going to get if you graph the 2 lines and they're parallel? Nothing. So what do we write as an answer? No solutions. You're right. No solutions, okay? No solutions at all if the 2 lines happen to be parallel. Because if 2 lines are parallel, would they ever intersect? Nope. What if you graph the 2 lines, okay? What if you graph the 2 lines? And Carly, they are one on top of one another. So what if you graph the 2 lines and they're one on top of one another? How many answers would you get?
Infinitely many solutions.
Why do we have infinitely many solutions? You're right. They are intersecting at every single point, okay? So we're going to start. It says graph the first line. Go and graph the first line. Y equals 3 over 2x minus 4. Aaron, can you help me graph the first line? How should we start?
You go down 4.
Okay, 1, 2, 3, 4. Yep.
And then you go up 3 to the right 2.
Thank you, Aaron. Up 3, right 2. And hopefully you guys have a straight edge ready. If you have some ugly line, your point of intersection is not going to be very good. So make sure you got a nice line. Okay. I have rulers, as you know where they are. Go grab them. ID is a great one for a straight edge and have it on hand. I normally make tons and tons of dots so that way my line is ultra straight. Okay. All right, got the first line. Then, Anthony, how do you grab the second line? What method do you want to do?
Isolate the Y.
Okay, so solve for y. Perfect. So guys, solve for y for me. So Anthony, when you solve for y, did you move the x over? Okay, so Anthony said I have 2y equals negative x plus 8. What's next, Anthony? Divide by 2. So y equals negative 1/2 x plus 4. All right, so go up 4. And you have a negative 1 over 2. How would you graph that? You have choices now. What do you want to do? Down 1, right 2. Down 1, right 2. Down 1, right 2. Can you go up 1, left 2? Up 1, left 2. Is that still okay? Yep, you can go wherever you want as long as you have the negative correctly. Oops, did not mean to do that. Then we are done graphing both. What's the point of intersection? What do we call it? McKenna S. Where's McKenna S? Okay, McKenna S. What's the point of intersection? What do you think that is? Four. One more time. 4 comma 2. Okay, x is 4, y is 2. Or I can write the equation another way. I can write x is, what's x? X is 4. Y is 2. Okay. You can write the point as an ordered pair, or you can write the solution as an x equals and a y equals. Because as you can see, you have a system. In this system, you have x variable and what? Y variable. So when you're solving for a system, you would need to have both to come out, x and y equals, okay? All right, I'm gonna move up a little bit. I'm gonna give you guys time to copy this chart down before we go and solve by using substitution. We're gonna follow those steps. These are the steps that you can read again if you are stuck at home doing your homework. Okay. Hope, can you help me read number 1, please?
Solve one equation for a particular variable.
Very good. Okay, so pick an equation, solve for a variable of your choice. Baron, can you help me read number 2, please?
Substitute in the other equation, there should now be only one variable present.
Very good. Madeline L., can you help me read number 3, please?
Solve the remaining variable.
Perfect. And Amanda R., can you help me read number 4, please?
Substitute answer back to either equation, set for second bit.
Perfect. So we're going to execute number 1 first, okay? Roger, number 1 says, solve for one equation. Solve one equation for a particular variable. Which equation do you want to use and what variable do you want to solve for?
Solve the first one.
And what variable would you like to solve for?
X.
Very good. So Roger said, I'm going to use the first one because it seems like the easiest one to solve for x. Do you guys agree with Roger? Okay. If you solve for x, what are you moving? 9. So x equals 3y plus 9. Did we solve for one variable? Good. And then number 2 says substitute that into the other equation. So the second equation, every time you see an x, what are you going to do now? What are you going to substitute with? 3y plus 9. So take this class, plug it in there. Okay, so I'm going to go, x is now no longer x. X gets 3y plus 9. Drop down the 2y equals to negative 1. Then you just solve for that one variable. Can you combine like terms? Brandon N. Can you combine like terms? Yeah? What do you get? 5y. Excellent. So 5y plus 9 equals negative 1. Okay. Lena, what's your next move in solving for y? Yep, move 9. So we get 5y equals negative 10. Okay. Anthony, what's your next move? Divide by 5. So y is now negative 2. I can box that up because that's one of the variables I'm trying to solve for. Then the last step said substitute that answer back into either equation you want. Which one's easier? Which one's easier that we should substitute that back into? That first one that we solved, couldn't we? Wouldn't that be easier to put it back in there? Because that one's already saying x equals. All right, you plug it back in there. You let me know what you come up with for x. All right, Kennedy, what did you come up with x here? 3. Okay, so let me see. X is 3 times negative 2 plus 9. X is negative 6 plus 9. And Kennedy is perfect. Box that up. I could also even write that as an order pair. Okay, Brooke, how would you write that as an order pair? Great job, Brooke. Perfect. Okay, so that's the point where it intersects. So that's how we do substitution. Now I'm going to move up a little bit so you can copy down the steps for elimination, and then we'll solve elimination, okay? Okay, we'll make it fatter really quickly, and then I'll pinch it back in so we have more space to write. So go ahead and copy down the steps to doing elimination. And as you know, you can always go to the YouTube channel and listen to this again if you didn't understand it the first time, or say a tutorial and I can help you. Jack, can you help me read elimination? First, what do we do? Thank you. Okay. In the same form, usually standard form is the easiest to eliminate. Sydney, can you help me read number 2? Very good. Number 3, Joseph, can you help me read number 3, Joseph M?
Multiply each equation by the appropriate number. Coefficient on the variable is eliminated.
Thank you. Hannah L, can you read number 4, please? Perfect. Okay. Kai, can you have me read number 5, please?
Solve for the main variable.
And last one, Aaron, can you help me read number 6?
Substitute answer back inside the equation and solve the second variable.
Perfect. Okay, we'll give you guys a couple more minutes to finish copying the steps, and then we will use the step to find the answer to number 3. And after this, we have 3 check for understanding, and that's the end of our notes. So Grace, which one of those 2 variables do you want to eliminate today? Y, okay? She said Y. Perfect. By the way, there's no right or wrong answer. Can you see the Y already have the Y variable here, first and second equation, they already have opposite signs? So that's a good thing, okay? Because when you combine them, opposite sign will cancel one another out. You can definitely eliminate X. You just have to multiply, one of it has to be multiplied by a positive number, and the other one just has to be multiplied by a negative number. So these 2 values of Y have to be exactly the same. What is the common number that we can use? How do we get them to be the same? What number? What number? What is it? For the Y's, because Grace says she wants to eliminate the Y. We're going to multiply the top by 5 and multiply the bottom by 4. That's right. We want them to be 20. Okay. So, since they are already in standard form, we are just going to go and multiply right away because Grace already decided to get rid of the Y. We will multiply the top by one more time. What is it? 5. And multiply the bottom by what? 4. Okay, let's distribute. Here we go. 7x times 5 is what? Brandon C?
7 times 5.
Uh-huh.
35.
Yep. Okay. Negative 4y times 5, Daniel F? Uh-huh. And here's a big one. 17 times 5 is what, James S? Uh-huh. 85. You got help? You guys agree? Yep. 7 times 5 is 35. 5 times 1 is 5, and there's a 30 from that, so we got 85. Okay. Next one. 3x times 4. Emma P is what? Good. 5y times 4. Braden N is what?
20y.
Thank you. 14 times 4. Gabriel, what's what? 66. 4 times 4 is 16, so we only have 56. Is that okay? All right, we're going to eliminate. Is the y gone? When we combine those two things. Negative 20y's and a positive 20y, they are gone. 35x and add it to Chan, 12x is what? 35x and 12x. We need to combine those two.
47.
Yep, 47x equals 85 and 56. Dylan H is what?
131.
Okay,
41.
141?
Yeah.
Okay. Then we're going to divide both sides by 47. X is. What is it? 3. We got X, class. Okay? We got X. Now, one of the steps says, when we add and subtract, we solve, we got X. Then the last step, so you have one of the variables, substitute this answer back into either equation. So now you have to choose which equation do you like better. Okay, so Emma H, which one of those equations do you like better to substitute the 3 back into?
3x plus 5y equals 14.
Okay, so Emma said I'm going to plug 3 back into the second equation, which is 3 times 3 plus 5y equals 14. 3 times 3 is 9 plus 5y equals 14. Take away 9 from both sides. 14, take away 9 is what, Brooke? Yep. 5y equals 5. Divide both sides by 5. So 5 divided by 5. X is 1. Beautiful. I'm sorry, y, not x. Okay. I'm also able to write this as an ordered pair. Okay. Carly N. How do you write this as an ordered pair?
3, 1.
Yes. Good job. So, you learn how to graph. You learn how to solve by elimination. You learn how to solve by substitution. Now, bottom 3. Check for you. Check for understanding. Do all 3 if you have printed notes. But if you don't, I'm just going to move it up one at a time. So that way you can see the equations. Okay? I'm going to put 3 minutes for each question. Okay, so once you have an answer, make sure you check with your partner because I'm going to ask you to share with me. If you get to the second check for you and the third check for you and something's funky, don't be stressed out. It's supposed to be funky. So put 3 minutes on. sure you make your tick marks evenly. Because what happens when your tick marks aren't even, then the dots aren't even, then where they intersect will not be even. So if you have printed notes, do all the 3 check reads, okay? All the chances. And again, if you have a second check view and a third check view, don't freak out. If something funky is happening. Certified elimination. Uh-huh. Great. So what do you have? What? If everything cancels out, what do you have? Oh, why? You said no. You said they would cancel. If all things cancel, what's left? Nothing. So what number do you use to represent nothing? 0. Okay, so let me ask you this question. 0 equals 17. Is that ever true? No, it is not true. Would you get an answer ever? So what kind of answer would you write right there? Huh? No, not send line. Remember, if it's not true, you write no solution. So if it's not true, you write no solutions. Okay, so Baron went all the way down to number 6, and he did check view 6, and he got 0 equals 17. Remember, that's never true. 0 is not the same as 17. So when you have an equation that's not true, there's no answer. Are we done with number 4, by the way?
No.
No? Okay. If you know number 4, go on to number 5. Okay, let me move on to the last check. I'll be right there. So 4, here are the questions. So that way I'm going to pinch it in a little bit so you can see all the questions. Okay. Okay, so 4 take away 4 is okay. And then what do you have left? So you can crop those out, right? Right. No? Okay, well, but you still have something on the left hand side. What do you have here? Okay, so write 2 equals 3. Is that true ever? No. So if it's not true, and there's no more variables, guess what kind of answer it is? No solution as well. Okay, I'm only asking to see if you can give me the answer 4, okay? 4, I'm going to ask 3 students. So can you share with your shoulder partner about the answer to number 4 first before I call on 3 of us? Just 4, okay? Okay, so after you guys graphed it out, Victoria, what is your final answer to number 4, please? 1, -4, all right. Hunter, the answer to still 4. Okay, Hunter, what's your answer to 4?
-3, 6.
-3, 6. Arista, what is your answer to 4?
Finished yet.
Okay. Delaney, what is your answer to 4? Okay, we'll wait for Rasan Delaney. Now, if you're on 5 and 6 and you're done, can you again compare answers with your partners?
Did you finish number 5? Number 4.
Remember, the bad thing about solving by graphing is you have to eyeball it, so sometimes it's not the best way to go.
So we only have one more page of mine? Yeah, so does that mean there are tests coming up? Since we only have like one more page of notes left?
Yeah, I guess.
That's exactly what it means. Whoa. That's what it means, Gemma.
Yeah, I guess we have tests next week.
Probably this week. I can't see it.
All right, so these are my 2 lines. Do they look about what you guys have? Go in the right direction at least? Every time I touch my screen, it changes. Oh, see? Yeah, Minecraft was pre-uploaded when I bought this thing. Okay, so looks like, I don't even know what to do with Minecraft. Okay, if I have to guess, I'm going to eyeball this, by the way, because as you know, graphing by hand is not the best. If I were to eyeball it, does it look like about -3 and up 1, 2, 3, 4, 5?
Yeah.
Okay. And again, remember, graphing, solved by graphing is not the best way to go just because what? Just because you have human error. Okay. Your tick marks might be off. Now, 5, as I was walking around, I saw you guys solve by elimination, and you came up with 2 = 3 at the end. Is that ever possible? No. So, guess what? When you see something that's not possible, you have no solutions. Then another student said, well, I did this, and I got, Baron, what did you end up with the last 2 digits down here? Yeah. 0 = 17. Is that ever possible? So again, you would have, let me ask you this. What if in another case, when you solve and you get 5 = 5? It's different. What kind of answer would you write? Infinitely many, because that is always, always, always what? True. Okay? So when you see 2 numbers that are the same, then it's always true. That means infinitely many. All right, borrow a graphing calculator. Work on your homework, please. You might have to share with the partners next to you.